In this lesson, we're going to compare properties of two functions represented in different ways, whether it being algebraically, graphically, numerically, in tables, or some kind of verbal description. We're going to given a linear equation or a linear function represented by a table, a linear function represented by an algebraic expression. We're going to determine which function has the greatest rate of change. Now let's talk about this term for a second, rate of change. We're going to hear this very often with linear functions. Rate of change is the same thing as slope. So when you hear rate of change or slope, both words are used interchangeably. Slope is denoted by the variable m. Okay, so when we say m equals, that's the slope that we're talking about. So in this case, m equals rise over run. Another notation, this is also known as the change of the y's over the change of x. Now let's talk about that for 1 second. If we look at this linear line here, okay, making a straight line linear function, we can see that this line has some kind of slope. If we read this graph from left to right, it looks like the line is going in an upward direction. It's an ascending or increasing direction. So this is going to have a positive slope. Now each slope, each positive or negative slope will have some kind of numerical value. Okay, so we want to find out what that numerical value is. So we're going to look at this graph and figure out what that is. We're going to look at the points on any intersection. Now, it doesn't matter what points you use, but what I would recommend is using points that fall right on an intersection, just like the one in the red here and this one here in the red as well. Okay, these are probably the easiest ones to use, easier to use than points that are not on the intersection. So going from this point to the other point, we can only move in a up or down direction and a left or right direction. So my formula here says rise over run. So the rise being either up or down, and this point from here, which direction do we have to go? So if we get to this point to the next point here, we see that we're going in an upward direction. Now if you think about the number line, anything that's going up is positive, anything that goes negative, anything that goes to the right is positive, anything that goes to the left is negative. So since I need to move up in an upward direction here, well then this is going to be in a positive direction. Now how many units do I have to go up? I have to go 1, 2, 3 units up. So counting 1, 2, 3 units up. So I'm going positive 3 units in the upward direction. And then I want to ask myself, how many units do I have to move to get to the next, to the dot there? So we're going to move from here, we're going to move this direction. So we're going to move to the right. How many units am I moving to the right? We can see we're going 1, 2, 3, 4 units in the positive 4 direction. So again, let's look at that one more time. From left to right, the first point we see here is here. We're moving 1, 2, 3 directions up. And then from here to the next point, we're going to use 1, 2, 3, 4 directions to the right. Moving up is positive, moving to the right is positive. So when I indicate my slope is going to be, well, what was my rise? Well, I rose 3, positive 3. And what was my run? Well, I ran to the right, so I ran positive 4. A positive divided by positive is a positive, so we could just say my slope here is just positive 3/4 or just 3/4. Let's look at another example. So again, we're looking for a slope. M equals, again, it's the rise over run. Now let's pick 2 points on this graph that fall right at the intersection. So if we go from left to right, and we just take this graph straight down, well, we see that this point is right on the intersection. And is there another point right on the intersection? Well, we could keep going, see if there's another point that falls right into intersection. More than likely, for test purposes, there will be some kind of point that falls on the intersection, and we see that this one here is on the intersection. It might be a little off, but for test purposes, hopefully the teacher or instructor will put the dots there for you, or the points there for you. So left to right, we want to get from this point here to this coordinate here. Now, which way do I have to move? Well, starting here, we see that, well, in this direction, do I move, again, we're going to do rise first. Do I have to go up or down? Okay, so if you look at it and if you said down, that is correct. So in this case, we have to go down. Now the question becomes, how many units do I have to get down to get to that line there? So I need to go down 1, 2 units, down direction, so -2. And then how many units to get to the right here? I have to go 1, 2, 3 units to the right, so it's +3 because I'm going to the right. So I had to go down, which is my -2, and I go to right, which is my +3. So my rise is down 2, my run is to the right 3. So I have -2 divided by +3. A negative divided by a positive is a negative, and 2 divided by 3 we could just leave as 2/3. So the slope here is -2/3. Again, starting from this point, I had to go down 1, 2 units, and then I had to move to the right 1, 2, 3 units to the right to get to that point. And remember, you can only use vertical and horizontal movements. So, and again, if we look at this graph from left to right, it looks like if you put a ball here, the ball is going to slide down, it's going in a downward or descending direction. So this is a negative slope. So before you calculate these slopes, look at the graph. Ask yourself, is it going up or is it going down? And again, always reading from left to right. So in this case, it's a negative direction. It's going down, negative slope. Now we have two special cases. But before we get to that, why don't you take a second and try this one. Actually, this one's the same graph. We have two special cases. It's case number 1. Now this is a horizontal line, and our second case is going to be a vertical line. So the slopes on a horizontal line and a vertical line are a little bit more entailed than the last two, where we're counting. If you have a horizontal slope, one way to look at this, if you were to put a ball right here in the middle of this line, and according to this line is perfectly level, which way would the ball roll? Will it roll to the left or will it roll to the right? Well, if it's a completely flat plane, it shouldn't roll anywhere, right? It should stay exactly where it is. Well, if that's the case, then that's exactly what we want to say. We say, well, it doesn't roll to the left, it doesn't roll to the right, it doesn't roll to the right. It has a 0 slope. So my slope here is 0. Another way to look at this is, again, by rise over run. Well, if we look at the rise over the run, let's take any 2 points. In this case, all these points are on an intersection. So do I have to rise to get to the next point? Do I have to rise to get from one point to the other? Well, there is no rise here in this case. So my rise is 0. And how many times do I run? 1, 2, 3, 4 in order to get for this particular example. So 0 over 4, 0 divided by anything is always going to be 0. So another way to look at that as well. The vertical line is a little slightly different. If we look at the same example as rise over run, well, if I want to get from one point to another point, let me go right on those. Well, how do I rise? Well, I have to rise 2, 1, 2 in the upward direction, or down 2, either one. And I'm not running either right or left. So there's no run to the right, there's no run to the left, which leaves me at a 0 in the denominator. So anytime you see a 0 in your denominator, and the 0, one way I remember this is when the 0 is underneath your fraction, when your 0 is underneath or in your denominator, then this slope we're going to say is undefined. So if the 0 is underneath, the slope is undefined. Okay, so these are two special cases for slopes. So if we go back, we have a slope going in the upward direction being positive. This slope was positive 3/4. This slope going down in downward direction being negative, negative 2/3. This slope being a flat horizontal line, putting a ball in the middle, it's not going to roll either right or left. This has a 0 slope, or if you did rise over run, it would be 0 over 4, no rise, all run. In this case being rise over run, where you're rising, and no run in this case. And this is your undefined slope. Your 0 is underneath, and it becomes an undefined slope. Now let's take a look at some other examples. What if you don't have a graph here? What if you're just given 2 points? Well, we have a slope formula. The slope formula is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, as other teachers will sometimes use y sub 1 minus y sub 2 over x sub 1 minus x sub 2. It doesn't really matter. Good practice would be, especially in the beginning phases, I would actually label these x1, y1, right? So these are coordinates, x and y coordinates. Those are your first x and y coordinates, and these could be your second x and y coordinates here, x2, y2. So when you go back and you fill in for your formula, you know exactly what you're filling in for. Now be careful. These negative signs here in the middle, or these minus signs, belong to the formula. And if the numbers or the coordinates have their own negative signs, we have to also include those. And let's see how that works. So we have m equals. So y sub 2, in this case, y sub 2 is 1 minus, which is this minus sign here, and then y sub 1, which is negative 2. So I'm going to put the minus sign that belongs to the formula and the negative that belongs to the number, over x sub 2, which is negative 3, minus, and then x sub 1, which is 5. So here we have, I'm going to erase this a little bit. So we have 1 minus negative 2, which is the same thing as saying 1 plus 2, 1 plus 2 is 3, over negative 3 minus 5, negative 3 minus 5 is negative 8, or we could just say m is equal to negative 3/8. Usually the negative sign goes in the middle of the fraction bar, or you could put it in the numerator. Very rarely do you see it in your denominator. Let's take a look at another example. So find the slopes between these two given points. Again, I'm going to use my slope formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now I would definitely recommend you write this formula over and over for every problem until you have memorized it. So I'm going to try to help myself out here, and I'm going to label x1, y1, and x sub 2, y sub 2. Okay, so y sub 2 minus y sub 1, so here I have 3 minus negative 1 over 5 minus negative 2. 3 minus negative 1 is the same thing as saying 3 plus 1. We get 4 over 5 minus negative 2 is the same thing as saying 5 plus 2. 5 plus 2 is 7, so my slope is 4/7. Okay, next one. Find the slopes between the given 2 points. Now what I would do here, what I would suggest is maybe pause the screen at this point, use the formula, plug in, go back and see if you got the answer right. So m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Going to label x1, y1, x2, y2. Now, if you got stuck on this one, there might be a reason why. So let's see what happened. So y sub 2, so we got 3 minus 3 over negative 6 minus 5. So we got 3 minus 3 is 0, negative 6 minus 5, and we have negative 11. So now here's something that should be going off, like a little red light going off. 0 over negative 11. So 0 over anything is always going to be 0. So in this case, your slope is 0. If 0 is in your numerator, your slope is 0. Okay, so I'm going to say that again. If 0 is in your numerator, 0 over anything is 0, so your slope becomes 0. Let's look at the next example. Find the slope of the two given points. Okay, again, so m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Labeling x1, y1, and x2, y sub 2. Okay, and I'm going to plug in. So we got 7 minus negative 3 over 2 minus 2. Let's take to solve this. 7 minus negative 3 is the same thing as saying 7 plus 3, which is 10. 2 minus 2, and I get 0. Alright, so here we go again. Then we have another 0 in my fraction. This time, the 0 is in your denominator. So remember what I said. If when the 0 is underneath, then the slope becomes, or your slope is undefined. So if your 0 is underneath your fraction, or in your denominator, your slope is undefined because you're not allowed to have a 0 in your denominator. Okay, let's take a look at a small application of this. So which function has a greater rate of change? Which function has a greater rate of change? So here's a table and here's a graph. So you need to find the slope here, and you also need to find the slope here and decide which one has a greater rate of change or which one has a greater slope. Well, these are coordinates. So this is like x1, y1, x2, y2. Okay? So it doesn't matter which ones you use as far as your coordinates here. Okay? So I'm just going to label this one. I'm going to take these two first ones. So -4, -3 is my x1, y1, and I'm going to call these down here my x2, y2. And I'm going to use my slope. So m equals y sub 2, so -2 minus y sub 1, which is -3, over, and my x is x sub 2, -2, oops, excuse me, -2 minus -4. Okay, so y2 minus y1 over x2 minus x sub 1. So this becomes plus -2 plus 3 is 1 over -2 plus 4 is 2. So the rate of change here is 1/2. Now going into this function, let's try and find 2 points on this graph. Well, here's 2 points, nice. Let's get those a little darker. So here's 1 point on an intersection, here's another point on an intersection, and let's see how we get there. So again, we're going to go rise over run. So to get from 1 point to the next point, I have to go up 1, 2, 3, 4. So I'm going up in a positive 4 direction, and I'm running 1, 2, 3, 4 to the right. So again, I'm going in a positive direction to the right. So my rise is +4, my run is +4, and +4 divided by +4 simplifies as just +1. So here's a slope of 1/2, here's a slope of 1. Who has the greater rate of change, or which number is greater, who has the greater slope? The slope of 1 is the greater rate of change. This next function, or the next, is very similar. Here's one problem, and the next one is another problem, also try. So let's take one at a time. Which function has a greater rate of change? Okay, we're going to use the same strategy here again. So we're going to use these coordinates here, and just for giggles, let's use the last coordinates here. So I'm going to say x sub, we'll call this one x sub 1, y sub 1, we'll call this one x sub 2, and y sub 2. Alright, so we got m equals y sub 2, which is 10, minus y sub 1, which is 4, over 4 minus 1, x sub 2 minus x sub 1. 10 minus 4, we get 6. 4 minus 1, we get 3. If you could simplify, I would definitely simplify. So this one has a rate of change of 2. Let's look at our graph. Let's pick 2 points that fall exactly right on the intersection. Here's one that I see, and here's another one that I see. Okay, so again, this is on the upward direction, so it definitely is going to be positive. I have to go here 1, 2, 3, 4, 5. So I'm going up 5 units. And I'm going 1, 2, and I'm going to the right 2 units. So my slope here is 5 over 2. And if you notice, it's 5 over 2 and 2, who has a greater slope? Well, 2 and 5 over 2 is the same thing as saying about 2.5. So the rate of change here, 2.5, is greater than your 2. One last one. Okay, so this one's a little bit more challenging. Which function has a greater rate of change? So this one gave it to us on a word format. The output of a function is equal to 3 less than the 5 times the input. Okay, when we talk about the output is the y term, or y variable, and the input is the x variable. So we have the y is the output, and we got the input as your x variable. So it says the output of a function, so y is, meaning equal, to 3 less. Let's highlight this one for a second. 3 less. Anytime you see 3 less or 3 more, let's put that in the back. So I'm going to take 3 away from something. What am I taking 3 away from? 3 less than 5 times the input. So 5 times x. And in the next lesson, we'll see that the coefficient in front of your variable, here x, in front of your input variable, is the slope. So here m is equal to 5. And let's see what the slope is here in the next one. And don't get too crazy about this one. We'll go over this one in the next video. So here, let's count our slope on this graph here. We notice we have to go up 1, 2, 3, 4, 5, 6, 7, and so we're going up 7, and we're running 1. So my rise is 7. My run is positive 1. So my slope here, rise over run, is just going to be 7. Who has a greater slope? The 5 or the 7? Well, the 7 is greater, so the function that has the greater rate of change in this case, or the greater rate of slope, is the 7.